So, and now it's the time for our next speaker, Soham Dasgupta, who is a technology enthusiast who's working at Microsoft as a solution architect with over 16 years of experience in software development, designing architecture, including on-prem, cloud-native applications, and web-based conversational application design. Please welcome the speaker.
Hey, thanks.
Hello, Soham. How are you doing?
Good, how are you?
Good as well. Thank you very much for joining. I see that you have a very exciting topic for today, right? So when it comes to orchestration and AI, both standing in one sentence, it kind of brings me the feeling of double complexity, right? AI is complex. Orchestration, well, at least some point in time, it was complex, probably still is in many cases, right? But combining two, right? It's some next level of complexity and problem-solving skills that is required, right?
Yeah, how do I put this? It's yeah, we know this is a complex topic, but the idea of giving this talk is to make it simpler. Who hasn't seen and tried out ChatGPT? If somebody says, "No, I haven't," I'll actually leave this call and go sit somewhere else. We have all done this, and what we'll try to do today is to actually show some ways to tame that technology and how you make it work on your own use case, tactics, and SDK. Because I'm going to talk about Semantic Kernel is one of the SDKs which is available in Java, and how you can use it actually on your favor to use large language models.
That does sound like a fascinating topic, and I'm looking forward to learn how to orchestrate the AI requests. And having said that, the stage is all yours, so please share your presentation and good luck.
Hey, hello and welcome to my talk about how to orchestrate AI with Semantic Kernel. Initially, I wanted to name it differently, to be honest, and I wanted to talk about why Pythoners will have all the fun. But somehow I thought, no, let's make it a lot more inclusive title, and let's talk about how you orchestrate AI with Semantic Kernel. Who am I? My name is Shoam. I work in Microsoft Netherlands, mostly with ISVs as a partner to help them solve or build applications on top of Azure with cloud native technologies. Before I go into the details of Semantic Kernel, let me give you a bit of a background on what generative AI is actually. It's not new, as I was saying previously. Who hasn't used ChatGPT? We all did in some form or some way, asking stupid jokes or trying to complete our code, or just trying to rewrite a email in a better way. But it all started quite a while ago, actually, around 1956, when artificial intelligence was first introduced. And then it came a long way. In 1997, the machine learning, and 2017 was the deep learning, and now the generative AI. We are standing in an era where AI is actually invaded in all our daily life. Everything around whatever we do has an impact on AI, or AI has an impact on it. And from the Microsoft point of view, I can say everything we are building have a touch of AI in that as well. So the hype about ChatGPT, within 2.5 months, 2.5 months, there was 100 million users. It was huge when it started. It broke all the records on how many active users were there every time. And we all have noticed when we started using ChatGPT, sometimes it tells you there are too many users and you have to wait. And we did, and we still used it. And slowly we also understand the type of way of engaging with these LLMs. and we call them prompts. I'm going to talk about prompt engineering a little bit later because that's also quite interesting part when we talk about orchestrating a UI actually. So what is this does actually is ChatGPT takes a natural language way of instructions and try to give an answer to it. Um, it's all based on a large language model. It learns from massive amount of text and data over the year, but it has a limited period of information to it. For example, GPT-3 had information till 2019, and GPT-4 is for 2021. So you cannot ask what is the current affairs related questions, but you can definitely ask things about forming a new um, sentence or forming a new paragraph or creating images or rewriting something, summarizing something, writing a poem, etc., etc., etc. How we are so far aware of using machine learning or AI is a very typical machine learning manner where you produce a label data and you fall through a model and it then does a specific job like classification of your data, entity extraction of your data, summarization of your data, identifying objects in a picture, writing a proper email, etc., etc. But all those things has a separate model required and a separate way of training required. When the large language model introduced, it was already trained on all sorts of different labeled and unlabeled data, and it can do all sorts of uh, operations that a normal machine learning language model can do. The the difference is you are not training it. You are only using that as an API and asking questions or giving tasks for it to perform. And various tasks. It can go from 1 to 100 different ways of doing it. And you're doing all of it using one large language model. So how these foundation models are being created? By the way, I'm going to talk about switching between foundation model and large language model. Both are essentially the same in terms of generative AI. They all falls on the same same kind of a classification, to be honest. So a foundation model is trained on not only text label data, it's also images, page structure, 3D signals, everything you can think of. And then it can do various tasks as question answering, sentiment analysis, information extraction, captioning of image, object recognition, and a lot of other things, which I couldn't fit in the uh, slide itself. But how large these models are? The demos and code that I'm going to show today uses GPT 3.5, but GPT 3 has 175 billion parameters. Thinking of writing a function which actually takes that much of parameter to produce a result. It's actually that. And GPT 4, which is released on this year, has 1.4 trillion parameters on the input level. So you can imagine how big these language models are and how much time and resources it took actually to train these models. And because it was based on so large of a data set, it has also a various kind of functionalities to work with, to be honest. But is generative AI a solution for everything? No. It cannot understand language. It doesn't know either. It cannot do math. I think you've all saw examples running on Twitter and LinkedIn about how bad GPT-3 was with mathematical problems. It cannot understand facts. So it only have a task in hand, and it has only the data it is trained on. So it try to create the most possible valuable answer that it thinks assigns to that task. It cannot understand manners or emotions or ethics. So it's a very large topic within Microsoft as well when we talk about generative AI, how responsible and ethical we make these generative AI is, because it is itself not that way. It also cannot understand anything. So it's basically a dumb engine which has a lot of rule sets and parameters and functions. It goes through and try to find the right path to give you a response to. So it has to be you have to understand these limitations of generative AI when you're working with them. So when you try to orchestrate, which is a topic of this presentation, the orchestration also needs to take into account all of these boundaries that you're gonna fit in. So what is OpenAI? It's actually a AI research company, but OpenAI and Microsoft had a 2019 tie-up, and all OpenAI models are actually also available or will be available sooner on Azure as well. And it grows. It started with Ada, then it came to Curie, Da Vinci, now it's GPT-4. So there are different models being released every year, and then they are all available via OpenAI as a paid API, or you can use it via Azure or any other cloud provider. So what it can do within the Microsoft Azure scope, we have GPT-3 and 4. We have a Codex, which is basically the coding companion when you're trying to generate codes or write tests or write documentation, etc., etc. It also has the DALI part where you generate images. It has also the Chat GPT where you actually have a conversation with a memory inside. So you can ask different questions, but it remembers what is the context during the whole conversation. Now that I gave you a bit of a background of generative AI, let me talk about a bit more on prompt engineering. Because I'm gonna use or gonna show a little bit during the demo of Semantic Kernel. So what is prompt engineering? Prompt engineering is based on prompt design, how you design a task or how you design or write the instruction for an LLM and large language model. For this example, in here, we are asking to extract the email address from this email. And we provide that email. So the email, hi John Doe to regards Chris Holder, is basically your input. And the extract mailing address of this email is basically the task. And you expect the large language model will come back with a mailing address from this email. So you will hope 123 Microsoft Way, Bellevue is the address you get. So it's a very basic way of designing the prompt. You might think, oh, this is quite straightforward. Does this need a section in orchestrating in UI? Actually, it does. The way you define your tasks and instruction and your input is the way you get the response out. So the way how much you fine tune it to provide examples, to provide clear instructions, it will be better in the job to take it out. There are a couple of examples, like at the top, you specify the instruction. So you say, classify a customer questions, and it choose 1 if it is about insurance, it choose 3 if it is about not relevant about insurance. Then you provide some examples to make it more applicable to it so that it can properly classify. And then you actually provide your question, and you expect the LLM will give you a proper answer back. So there are different ways to do it. The very familiar or known way is zero shot and few shots. The zero shot is where you do not provide examples and you just provide the instruction and you just provide your question and you expect it to get the answer from. The few shot provide examples. So if your task has an ambiguity or the words in the task has resemblance to some other word in English, but you want to use it for a different specific example, then providing examples will give LLM more context on how to do the job properly. Why would we do that? We do it to reduce hallucination. because we are all familiar with how weird answers a chat GPT can provide when you're using it. So the chat GPT is based on GPT models, and GPT models will behave the same if you do not do that properly. So you have to include proper instruction, you have to restrict the output. So if you do not want things to be generated or you want things to be negated, here comes the inclusivity and a responsible part. You also want to add the chain of thought style. So um, uh, if you want to give a math problem, you want the large language model to learn how to do the math. You also want to have a repeatable way of doing it, and you also want to have the latency small. So you also want to make sure your prompt doesn't go beyond certain limit, because these APIs has a limit of how much tokens it can process. Tokens is, you can loosely relate to syllables or words, but they have a limitation. So you do not want your prompt to be very huge. It has to be properly placed with a limited amount of instruction, but also very much um, um, to be too direct to make it happen properly. So as I was saying, it is very bad in math. So if you just ask a mathematical question, it might come up with a answer which is not correct. I say might because it can also possible, it can come up with the right answer. That's the beauty of with large language models. They are non-deterministic. It's not always 1 + 1 = 2 in their reasoning. So if you want it to do a mathematical problem, a few short reasoning is always helpful. So you provide a example problem, you provide an example answer on how you came to that answer. And then if you ask a similar problem, it will do the right job and it will give you a proper answer back. You can also add chain of thoughts to explain it step by step. Uh, when this is required, so when I'm going to talk about later on how you code this, at the time of development, you also want to know which all steps has happened during that behavior. So at least you can validate the step. The results is a natural language output. So that can vary every time. You cannot match step word by word, but what you can match is whether the steps that it has taken to reach the answer remains always the same. So always try to try when you're debugging something with large language model, chain of thought gives you an extra edge to identify if there are problems in the reasoning process. So there is another example on how you extract the reasoning and how you extract the answer, and then you can easily check whether these are working properly. Now that we have talked about prompt engineering a bit, let me put semantic kernel into the picture. Before I put semantic kernel in the picture, let me explain how we used to build AI applications up till now without generative AI. So we used to have a lot of data somewhere in data warehouse, database, or a data store. You used to hire somebody who are very knowledgeable in building machine learning models, always a Pythoner. There comes why I wanted to name it, why Pythoners will all have the fun. Then you build a model and then you wrap it around the endpoint, and then your product can use that endpoint to make use of that model. But the cognitive, the Herbert Simon, the AI pioneer, said the LLM provides a cognitive blade. So it has a pre-trained foundation model. What you do is provide a context or knowledge to perform a task. So you have a large language model API, you design your prompt, you provide some context or data in form of vector or any other, also a natural language data, and then that's being used in your product actually. So the whole process of having something, an integrated AI in your product, has less steps needed to do that. So you have an LLM API which understands prompts, which takes tokens, and which also understand embeddings, which are vectors and a number representation or an n dimensional representation of the data. You design your prompt, which can pass on to the LLM API, along with your vectorized data. It can be normal or it can be a vectorized one. And there are different databases available to do it. There is VV8, there is Quadrant. Um, you can also embed using large language model, GPT models. You can also use, if you use Azure Cognitive Search. And then you can also store it in Redis as well. You can store it in MySQL as well. You can store it in Apache Cassandra as well. So all databases have a vectorized part to store your data, and then you expose it in your intelligence app. Where does semantic kernel fit in? Semantic kernel helps you in the two part: how you design or maintain your prompts, how you use it, and how you vectorize your data. So the SDK that I'm going to talk about is going to be helping you in those middle two part. Is that the only thing? No, actually not. LangChain is the oldest AI orchestration SDK, but that has only officially supporting Python and TypeScript. It has a LangChain 4J for the Java version, but it is also quite new as semantic kernel. You can also use Haystack for it, to be honest. But semantic kernel is another open source AI orchestration SDK. You can use it with Azure Cognitive Search, which it stated for vector database, but trust me, you can use any vector database you want on that perspective. And you can find them on GitHub. They have a Discord channel. I'm going to show the GitHub repo in a bit. And they also maintain a blog on their new implementations and improvement. I have to tell you here, the Java is still on a branch. So it is an alpha release, not yet merged to the main branch, but it's soon going to happen in a weeks or months time. The initial planning was end of September. So I am actually hoping end of September they will announce the release of it. But it's still on a branch in this GitHub repo. Should not stop you to experiment with it because it's more or less available, and I'll show you how to do that as well. And with that, I'm gonna quickly show you how that looks like. So I'm talking quite a lot. Maybe it's better to show you the code. To start with, let me show you my POM. My POM has a few dependencies from semantic kernel. The core is one which you need to start with. Then I'm gonna later on talk about plugins and connectors. Then you would need plugin and connector APIs. If you are interacting with a vector database such as cognitive search, you might need that. If you are interacting with some other other vector databases, you need that dependency as well. And I'm going to talk about the planners part as well, which is quite interesting. But okay, let me start with the simplest example. What it is doing is creating a kernel object. The kernel is the base of everything. So it's here. The kernel is a base of everything where you provide what is your endpoint for the Azure OpenAI stuff. By the way, before I go there, let me show you this. Right now, Semantic Kernel supports OpenAI, Azure OpenAI. There are versions to support Hugging Face and your custom models as well, and they are coming. You see this green check mark, that means it is done and coded, and in some cases it will come soon. So there is still a cross mark. So I would suggest if you are interested, keep an eye on them, and you will see how that ends up here. So in my example, I am actually looking at three different components. my endpoint of Azure OpenAI, my key to connect to the OpenAI, and the deployment name. What is the deployment name? The way Azure OpenAI works is basically you create a deployment on the model. So depending on which model you want to run. So for my case, I'm running GPT 3.5 Turbo. I created a deployment, and that deployment is actually I'm going to use to run all my AI orchestration. I also have a second deployment, which is text embedding Ada. This is used for vectorizing your data. I'm going to come to that in a bit later. But my inline function is basically creating a async client. Then it creates a kernel. The kernel is based on my deployment and where the endpoints are. After that, what I'm trying to create is a sample prompt. I'm saying I'll provide an input, and can you summarize the above thing in less than 140 characters? And then when I'm invoking it, I invoke with a few properties. So how many tokens I'm using, what is the temperature of it, how much top I'm going to provide it. The interesting part here is the temperature. So 0 means it is very deterministic, and 1 means it is very creative. So you cannot, so I kept it in middle so that I get a little bit of deterministic and deterministic mix. But you can also play around with this a bit to see how the results sum up. When I invoke with a text to summarize, so this is my text which I'm trying to summarize basically. So I'm saying text out of the documentation of Semantic Kernel, and I'm asking it to summarize it. So I added this prompt as a template to it, and I provide the input part of it when I'm trying to invoke it. If you look at carefully, I am actually making it very reusable, my prompt. And every time I change the text to summarize variable, it will use that as an input to run that. So what happens if I run this? So it'll try to access OpenAI, and it'll show you the rendered prompt. So this was my input, and this was my instruction, and this is the result it produces. So it actually did the job which I asked it to do. But there's a lot of text, to be honest. How would I make this easier? Now comes the part where I provide this as a very reusable manner. So in Semantic Kernel, you have a way to define plugins. What is a plugin? So plugin is basically a text file and a config file. What is a text file? Text file is basically your instructions along with all the stuff that you want to do. So basically here is a bloated version of the summarizer where I specify which rules it needs to do, what are the band phrases, and then provide an example to it, and then I end it. The config JSON is an optional part of it, where it actually provides how you initialize the kernel, so the max tokens, temperature, etc., and you can play around with that. So that makes it very reusable for Semantic Kernel to use. And what you do is you import the skill from the directory, you specify what is the skill name and where it lies, and then you use a function from that skill. So my skill here is a summarize skill. If you see this, it's quite small, but if you can read it, it's a summarize skill where I have multiple functions available. So if I want to make an abstract, if I want to create some notes, if I want to summarize, or if you extract the topics out of a text. So I'm using a function called summarize within the skill. And then it's basically the same. I specify the variable, which input variable it needs to take, and I run the function. So in compared to the previous example, it makes it much more simpler. And this is one of the way to do it. The previous is basically an intro to semantic kernel. This is basically how you should use it in your daily life. You can think of, I put it on the resources folder, but you can also think of making it a library or making it a Git submodule and share it along with different repositories you have. And ideally, it should produce the same results or very similar results from before, because it's a large language model and non-deterministic. So it will be a little bit different than the previously. So you still will see what is the rendered prompt, and then you will see the output as a prompt. So here I didn't provide the number of characters, so it make it a bit bigger, but at least it is pretty similar to the previous one. But as I said, it is pretty non-deterministic. So yeah, it will give you a different result every time. So I talked about plugins a bit. So it's a group of functions that you can use with the AI applications, and these functions will give you a different options to orchestrate your AI. So for example, you want to generate an email, or you want to create a JSON structure out of a table. You want to create an XML out of a table, stuff like that, and it'll basically give you the manner of reusing these options in a very in semantic kernel. As I said, it has a prompt skprompt.txt, where it is a mandatory stuff within a plugin, where you specify what needs to be done, and you specify your rules, your not allowed stuff, your examples. So you can go all creative over here, using all sorts of prompt design, prompt engineering techniques. And it also comes with an alternate optional config.json, where you can actually specify what this is about and what are the parameters for when you're invoking the LLM, and what are your input parameters and output parameters. Now I'm going to talk about a little bit about planners. So what is a planner? Before I go there, let me show you something as a skill plugin. So I showed you the way how you can do it with skprompt.txt and config.json, but there is also a declarative way of doing it. For example, with annotations. So this is a very basic texting skill. You can think of implementing your method the way you want to. Right now, I'm doing an upper and lower case, which just for the sake of an example. How you can define is you define an SK function, you give it a description, and then you specify the method with what is the attribute as an input. And then you use it inside your implementation as if you are instantiating a new object. So it is much more typed way of doing it, rather than reading a file from a file system or in your class path. They both have their pros and cons. I mean, if you do an skprompt.txt, you have more options to design your prompt. On the other hand, if you do it on a typed way, you will have a little bit less, or your options are a bit limited on that aspect. Then a little bit on a skill pipeline. So for example, before I go into the planner, because this is quite required for you to understand. So for example, if you want your application to do several steps, not one, not summarize and give me output, but you also want to, for example, rewrite it in a different way. For example, in this class, I am actually trying to make it uppercase after summarizing it, and you can chain these functions. So all starts with a kernel. You create a kernel. By the way, these all codes are available in my GitHub, and I'll share the link in at the end of the presentation, so you can all go and check. And the README also is there, how to set it up. So don't worry about that. So all starts with a kernel. The kernel is we add a couple of skills to it, and then for a specific input. So for example, in here, I am trying to summarize a chat transcript. and I'm saying summarize it and then make it uppercase. So what the LLM will do is firstly call the semantic kernel will do is first call the LLM API to summarize. And once it gets the results, it'll apply the second skill, which is uppercasing, to the results. In this case, I'm not calling the LLM again, but you can also think about calling the LLM again if you want to rewrite it in, I don't know, Yoda style, or translate it to a German or something. So you can create these kind of skill pipeline or function pipeline in your AI application to do multiple steps along with the results. And semantic kernel will take into account passing the results from first to second to third to fourth. And you can chain as many as skills and function as possible. So for example, here, if I run this example, I will get a summarization of this whole chat transcript, and it'll make it uppercase for me. So you'll still see how the prompt look like. So the whole thing with the summarizer, and then after that, it'll show me it in uppercase. Then a planner. So what is a planner? Let me go back. So now that you saw how you do pipelining with different skills, you can think that this might be a challenging part for me. So if I have multiple things to do I need to create multiple implementation of my application using semantic kernel? The answer is no. You might not need to do that. There comes the planner. So planner is it's a very specific to semantic kernel. It is not available to LangChain or any other SDK that's available for orchestration with LLM. So planner gives you the advantage of adding as many skills possible to your kernel, to your semantic kernel, and then using your prompt engineering skills, make sure it only invokes a few of them or one of them. So there are different kind of planners available: basic, action, sequential, and stepwise. I'm going to show you the sequential planner. So where it actually has a lot of skills added to it, but depending on what I ask, it picks up the relevant one and perform the task. So uh, for example, you have added in your semantic kernel implementation, summarizer, translator, email generation, create a poem, rewrite, ideate, etc., etc. And when you said, this is my input and only define an email for me, so it'll try to summarize the whole stuff or define the whole problem in that input and try to create an email out of it and give you the result. And it'll do it on the runtime. So the planner is basically finding out what thing to do at the runtime itself. So how does it look like? So what I'm doing here is, again, starting with a kernel creation, and then I'm adding a few skills to it. I added a writer skill. So the writer skill is basically can do a lot of stuff. It can acronym generate, it can brainstorm, it can generate emails, it can rewrite, storytelling, etc., etc. I'm adding summarize, which I've already showed to you with summarization, extracting topics. And I've also added the design thinking skill. So that means it can ideate, empathize, etc., etc. And then I create a sequential planner object with a lot of configuration parameter to it. I urge you to go and check their documentation on how to do it. And then there are 3 examples. So what does summarize and translate does? So I provide a text to it, the semantic kernel documentation text. And what I say is summarize the Java content and translate it to Dutch. Translate it to Dutch. And similarly, another example where I say rewrite the content in Yoda Star Wars style. summarize, apply design thinking on the above transcript. So depending on what you asked to it, it'll intelligently pick up which all skills to use, basically. So in matter of time and everything, let me just run one example, which is the summarize and translate. So it has a longer output when you see. So it'll try to say all the available skills that it has to do a particular stuff, and then it'll pick up which all things it can use to do that task. And summarize this didn't pick up my summarizer. Should have been. Anything and everything can go wrong, will go wrong. How about other example? Okay, the one I wanted to show didn't work, but at least this one worked. So basically, it wrote the the summary of this whole conversation into in a way that Yoda would say, and it picked up two different style to it. So it uses the input as text to summarize. So it tried to summarize this part, and then it rewrites it in a style where Yoda normally says. So basically, even though I provided a few more skills to it, like design thinking and writer and summarizer, which has multiple skills within it, it only picked up two to define the task rather than execute the task, not everything. So that's actually quite a huge benefit of not writing multiple applications to do multiple different jobs, but rather write one application and intelligently define the task need to perform, and it'll pick up the way it to do it. Before I talk about vector databases and how to use vectorized data within semantic kernel, I want to talk a bit about what embeddings are. Embedding is a special form of data. It is an n-dimensional number array, and it actually represent your text in that way. What does it mean? It means if you ask or if you provide a sample text to it, it'll try to convert it into a numerical array with an n-dimensional space. So it's mapping those things into a number. What does that mean? So if you have a simple example, if you have a realistic picture and a cartoon picture, and then you provide another dimension to it, mammals and birds, then you try to plot different object to it. So a cartoonized bird will be at the below, but on the right. The realistic looking birds will be below, but on the left. And mammals are at the top. So when you ask this someone, if I have a bat, which looks like a cartoon, where would I plot it? And the way the embedding, the way it's going to map it to find out what is the closest matching object that is represented by this. So basically it tries get the user input, create a numerical and dimensional array, and try to find out in its numerical space where this n-dimensional array is closely can be placed. So it try to find the similarities between that. It's not the semantic or textual search that we are all familiar with, but it is a different type of search where it tries to plot every aspect of the data it gets as an input and every aspect of the data that it has, and try to find what falls very close to it. So what you can do with it, you can do with clustering, you can do anomaly detection, you can classify your data using it. But it also has a implication on a design pattern that we call retrieval augmented generation. What does that mean? It means that the design pattern asks query the data to get a vectorized um, uh, result out of it. It adds those result as a prompt along with your question to large language model, and it gives you the answer. We have all seen the use case of query your own data, but this takes the query your own data to another level where you make sure your data is represented as a vector and your questions are also translated into a vector to have a larger possibility of relevance when you're matching that data. So when you use large language model sometimes to also make it vectorized your data. So it's actually providing the documents to the OpenAI service or Azure OpenAI service to get that happen. So let me show you an example of it, how you do it. I'm going to show you an example which uses an in-memory vectorized data. Uh, so everything starts with a kernel, but this kernel is an embedding kernel, and this is where I'm going to use this second deployment. Um, I'm not going to go inside that, but you can see the example in the GitHub repo. And what it does, it store some data. So my data here is basically a map of which URL we have and what kind of information is there in the URL. So basically, there are different URL on the semantic kernel documentation page. And then I store that in the memory. And how I store that is basically using my kernel. And this kernel, when I created it, I created with a volatile memory store. So this is basically an in-memory store. Alternatively, you can also use cognitive search or any other vectorized database along with it. So Redis, Postgres, Redis, MySQL, VVet, Quadrant, etc., etc. And I store that data along with some value and key and some description along with it. And when after I store it, I try to search that memory. I say, how do I get started on semantic kernel, for example? What it does, it try to extract the results from the vectorized data. So it try to find out which all relevant memories or relevant vector data I have, and then it used that data to create another kernel and query it. So here actually I'm providing the context to my second call to LLM. So this first call makes it vectorized. Then I query that data, which doesn't include LLM, by the way. And then I use another kernel basically to summarize that fact or give me a summarized output along with the memories as well. So I provide the memory to search with it. And it uses that memory to give me back that data. I hope my demo gods are with me to show you how it works. Cool. So what it does, it found the relevant information. So it said this URL and this URL may be something which you can use to start how you start on learning. And then I used that information to summarize it, and it summarized that the first URL is actually tutorial on how to get semantic kernel, while the second URL is AI orchestration in .NET. So last but not least, a sample representation on how semantic kernel works actually. So you provide a question. That question is parsed by semantic kernel. Uh, Either it goes to the embedding model to find out um, whether there is a relevance match to it, or it finds out from a vector store, which is can be anything. And then it uses that context to get more variable maybe. So using your search engine or any other API that you have, and it populates a prompt along with all this information. And once it has that, it queries again the GPT model and get an answer back and gives you an answer back along with all the memories and the context and the prompt you provided. So this is how a sample retrieval augmented generation works. And the way we limit the GPT model to only take into account the information we provide out of vector store, out of APIs that we call, is called grounding. And grounding an LLM is also basically, it's one of the design pattern of grounding an LLM is RAG, a retrieval augmented generation. There are a lot of resources. First of all, the GitHub repository that I used, and I can show you that. There's a Microsoft one. And that's the one which I mentioned. It also has the detailed blogs on how to explain it, how to do it with Java, the basic start and the planners. It has explanation on how to do the prerequisites as well, and also which all examples is for what. It also have further reading documentation as well. So if you're interested, please go ahead and check. This is the official repository of Semantic Kernel. The Java is in an experimental Java branch. So if you want to use the Java part, you need to basically clone this repository, build locally to run the application. But as I said, I'm expecting these to be merged to main by end of month or soon. It also has a documentation site where you also find all the information on how to do it. But since Java is not merged to the main branch, you will not see the Java part here. But all the examples are pretty much similar. You can also actually check the samples in the Java repository, which are also pretty much similar or more extensive than I showed in my repo, to be honest. And with that, I think I can stop and ask for if there are any questions.
Thank you very much for the presentation. That is indeed very inspiring, and the whole structure of code makes it quite easy to understand how the different modules are working together, and gives this kind of semantics and good structure to the application itself, right? We don't have a huge amount of time for the question. Your presentation was right in time until the end of the time slot, but I will still ask a couple of them, right? So first and foremost, it's more on the practical side of things. If you have a certain task to go through with an AI, and you showed an example with making things, let's say, uppercase, right? Does it make more sense to give one large prompt to the AI and to the model and prompt it to answer in the Yoda style to this question and also make it uppercase? Or does it make more sense to take it step by step and take the first part of a task, answer in the Yoda style, and then implement the second part of a task as a separate prompt?
If you ask me, I think the question's answer is more or less how we develop or write a method within Java as well, how nuclear you want to go. But the answer, you might hate it, but it depends.
Yeah, it depends
on how you want to use it.
Yes.
If you want to reuse basically different kind of plugins, then I would suggest make it as nuclear as possible. Then you have more ways to reuse it, basically, different parts of the application.
Mm-hmm. And the second question will be, this framework looks great, but do you think that every AI application should be relying on this or a similar type or of an orchestration framework, or there are cases where you might want to go and write your code completely from the scratch and implement some sort of a, I don't know, flexibility or approaches that are not supported by this framework, or it should be used by everyone pretty much because it's going to be standard?
Well, there are pros and cons. So yeah, there are pros and cons. If you want to interact with a large language model, my suggestion would be use not this, but at least one framework which help you make your code less verbose. So you rely on the library or the SDK to make your life easier when you write code, and you only invest designing the prompt or making your application doing the business logic, basically. So yeah, I definitely suggest, if you're using LLM and planning to using LLM, think of a framework which you want to use. It doesn't have to be Semantic Kernel. It can also be LangChain or any other. But it also depends on which LLM you want to connect to. If you want to connect Hugging Face or Llama, then there are limitations as well. Not all is supported. LangChain supports everything right now, whichever came out so far. Semantic Kernel doesn't. So on that case, LangChain would be much more interesting for a person who wants to use Hugging Face or want to have that customized. Today I want to use Llama, tomorrow I want to use something else. Then it's much easier for them to switch.
Does it make sense to combine the two? Let's say I want today to use Llama and something else. Are there such use cases in the industry, or it doesn't make
sense? Yes. You can combine them, because these are modular application, and you create an object and use that object to connect to the LLM. So at the end of the day, it's basically an object. Yeah, practical perspective, I would not. I would not mix and match. Because anyway, these large language models are non-deterministic, and if you provide multiple large language model within one application, then it will become
more non-deterministic, right?
More, yeah.
And one more topic, it has been a hot question for today. So what is your view on the data privacy for enterprise? This question has been asked a few times, but it's always nice to hear.
Okay, I'll give you two answers. One is the commercial answer. Commercial answer is Azure OpenAI. If you use Azure OpenAI, your data is not going outside your own subscription. If you use OpenAI, the normal OpenAI endpoints, there is a fine print that your data can be used for further training. But there is an enterprise version of OpenAI as well, which also provides you the data privacy. So all of these LLMs that are there, they have two versions. One version which is publicly available and you don't have control over your own data. An enterprise version which has basically control over your own data. So I always suggest, think of that before you're trying to do it, because before you know, the document that you want to summarize, which is a contract for your customer, is being used to train the next LLM version. So before you use ChatGPT, before you use any GPT model or any other model, basically, make sure to read the fine print, because that might land you in a different situation if you don't do that.
Thank you very much for your answers, and thank you very much for inspiring presentation, and especially thank you for the live coding. I know the pressure that it takes to code and write things in front of a few hundred people, and yeah, thank you very much for showing how it really works in the real life. So,
no problem. Thanks a lot for hosting me.